Hello everyone, welcome to my class. Now I'm going to explain about new topic, that is carboxylic acids and their derivatives, which is there in the second year organic chemistry. So now I'm going to explain about carboxylic acids, nomenclature, classification and preparation methods of carboxylic acids and physical properties of the carboxylic acids. So let us see the introduction of the carboxylic acids. So carboxylic acids, this is the structure of carboxylic acids. So C double bond O, OH. So this is the functional group. This functional group name is called as carboxylic acids. C double bond O, OH. Here, this carboxylic acid compound hybridization is sp2 hybridization, because this carbon which is having one pi bond and three sigma bonds, hence this carbon hybridization is sp2 hybridization. That means one s orbital and two p orbitals of this carbon, it is involving in the hybridization and making four bonds. And here it is the one is here it is the pi bond. And here generally, or here it is the alkyl group, the left side group is the alkyl group, or C double bond O, OH, this is called as carboxylic acids. These carboxylic acids isomers are esters. Esters are nothing but or C double bond O, OR. So coming to the classification of the carboxylic acids, so here depending upon the number of carboxylic groups, they are classified into mono, di, tri, poly carboxylic acids. For example, if you see here this formula HCOOH, this compound name, this is the general name of this compound is formic acid. Whereas here in place of hydrogen, here methyl group is present, so this name is called as acetic acid. So here in place of hydrogen, here ethyl group is there, so this name is called as propanoic acid. This is the acetic acid is the general name. Formic acid, acetic acid and propanoic acid. And the carboxylic acids which are having the more than 12 or 10 carbons, so those compounds are called as long chain carboxylic acids. Those long chain carboxylic acids are also called as fatty acids. Generally we will see these fatty acids in the oils. So here, for example, for the fatty acids, here C15H31, so here 15 carbons are present, COOH. This fatty acid name is called as palmitic acid, whereas C17, here in this fatty acids total 17 carbons are present, C17H35 COOH. This fatty acid is called as stearic acid. So long chain carboxylic acids are called as fatty acids. And examples for dicarboxylic acids. So here COOH group which is directly connected, carbon-carbon directly connected. This compound name is called as oxalic acid. Oxalic acid. Whereas here two carboxylic acids. These are all examples for the dicarboxylic acids. So here two carboxylic acids which are separated by one methylene group. So this compound is called as malonic acid. Whereas in this compound, two carboxylic groups which are separated by two carbons, CH2, CH2. So this compound name is called as succinic acid. Whereas here two carboxylic groups which are separated by three carbons, then this compound is called as glutaric acid. So here these two carboxylic acid groups which are separated by four carbons, so this compound name is called as adipic acid. So these are all examples for the dicarboxylic acids. So here two carboxylic acids which are directly connected, this name is called as oxalic acid, whereas here two carboxylic acid groups which are separated by one carbon is called as malonic acid. Here two carboxylic acid group which are separated by two carbons are called succinic acid. Here, two carboxylic acids groups which are separated by 3 carbons are called glutaric acid, whereas here two carboxylic acids groups which are separated by 4 carbons are called as adipic acid. The short form of remembering these names is called, first the compound name oxalic acid, so O, and his second name is M, third name is S, fourth name is G, fifth name is A. So short form to remember all these dicarboxylic acids names: O for O, M for my, S for such, G for good, A for apples. Generally, we can remember as oh my such good apples. That means O for oxalic acid, M for malonic acid, S for succinic acid, G for glutaric acid, and A for adipic acid. So these are all examples for the dicarboxylic acids. Whereas aromatic acids are nothing but benzene which is connected to the COOH group. Wherever COOH group is present, those compounds are called as carboxylic acid. So this compound name is called as benzoic acid. So whereas here in this compound, this is the benzene ring which is directly connected to COOH group and COOH group, and this compound name is called as phthalic acid. PHALIC, phthalic acid. Whereas here this aromatic compound which is connected to the COOH group as well as CH3. Generally, on the benzene, if only one substituent, that is methyl group, is present, generally that name is called as toluene. So here this toluene adjacent COOH group is present. So hence this is the ortho connection. Hence this compound name is called as orthotolic acid. And another examples here. So here this is the two substituents which are present on the benzene, and these are separated by 3 carbons, 1, 2, 3. Suppose if two substituents which are separated by 3 carbons, then that position is called as meta. So first position, first substituent, next position is called as ortho, next substituent is called as meta, next position is called as para. So here, if on the benzene, if methyl and carboxylic groups both are present, then that name is called as metatolic acid. Similarly, here this substituent position is called as para. So here it is a paratolic acid. So in this compound here on the benzene which is having both OH group as well as carboxylic acid groups, hence this compound name is called as salicylic acid. This name is called as salicylic acid. Whereas here on the benzene, if two COOH groups, those are carboxylic acids groups which are present in the para position or opposite direction, then that compound name is called as terphthalic acid. Terphthalic acid. Next, if you see here, if you see the nomenclature of the carboxylic acids, so according to the IUPAC nomenclature, we have to add the suffix as oic acid, oic acid for the number of the carbons. So for example, if you see this formula, in this formula, this is the HCOOH. So for this compound, common name is the formic acid. This formic acid generally which is available in the red ant. And here according to IUPAC nomenclature, in this compound only one carbon is present. Whenever one compound is there, then we have to write the methane, or then we have to add the suffix as oic acid. Hence we have to write the methanoic acid. So similarly here, this is in this compound CH3COOH is present. So for this compound, the common name is acetic acid. This is also called as vinegar. So here in this compound, total 2 carbons are present. Whenever 2 carbons are present, then carbon chain name is called as ethane, and then we have to add the ethane plus oic acid. Then its name is called as ethanoic acid. Whereas in this compound here, total in this straight chain, first we have to see, whenever we are writing the IUPAC nomenclature, first we have to see the longest carbon chain. So here 1, 2, 3, 4, this is the longest carbon chain, and first numbering we have to give to the functional group side, and at the second position which is having the one substituent, that is the methyl substituent. Hence we have to write the first, we have to write the substituent name. So 2 methyl, so total 1, 2, 3, 4, 4 carbons are present, hence the IUPAC name is 2 methyl butanoic acid. So like this we can write the IUPAC nomenclature of the carboxylic acids group. And similarly, whenever long chain is present in the carboxylic acids group, so carboxylic acid adjacent to carbon is called as alpha carbon, next adjacent to carbon or second position carbon is called as beta carbon, and third position carbon is called as gamma carbon. So we can also write the nomenclature whenever, suppose for, if you see this compound, in this compound, so here at alpha position or first position which is having the OH group, so we can write the alpha hydroxy. So here total 1, 2, 3, 4, 4 carbons are present, hence we can write the butyroic or butyric acid, or we can write the butanoic acid. Similarly, in this compound also, carboxylic acid adjacent to carbon is called alpha carbon, next carbon is called beta, next carbon is called as gamma carbon. So here substituent which is present on the gamma carbon, hence we can write gamma hydroxy butyric acid, or we can write the gamma hydroxy butanoic acid. And coming to the nomenclature of the acid derivatives, because these acid halides, anhydrides, all these are the derivatives of the carboxylic acids. So let us see the IUPAC nomenclature of these compounds also. So whenever we're writing the IUPAC nomenclature of the acid halide, then we have to write the oic acid, we have to replace with the OL halide. OL halide we have to replace. Wherever oic acid is present in the carboxylic acid, that word we have to replace with the OL halide. For example, if you see this compound, this is the acid halide because this is the derivative of this carboxylic acids, because in the carboxylic acid wherever OH group is present, that OH group is replaced by the Cl, hence this is the, these acid halides are derivatives of the carboxylic acids. So here in this compound total 2 carbons are present, hence we can write the ethane plus, and it is the acid halide. Acid halide is nothing but the compounds which are having the C double bond O Cl, then those compounds are called acid halides. Whenever acid halide is present, according to IUPAC nomenclature, we have to write the OL halide. So ethane plus OL halide, so or here halide is the chlorine, hence we can write the ethanoyl chloride, and common name is acetyl chloride. Similarly here, this is the phenyl group. So and here which is having the phenyl group which is directly connected to the C double bond O, hence this compound is called as benzoyl chloride. Benzoyl chloride. So anhydrides also derivatives of the acid groups. So in the acid CH3 C double bond OH, that OH group is replaced by the another, that C double bond O CH3 group, then those compounds are called as anhydride. So whenever we are writing the IUPAC nomenclature of the anhydride, then we have to remove the parent acid by replacing the ending acid by anhydride. So for example, if you see here, this CH3C in the anhydride structures, CH3C double bond O, this is the repeating structure. So here it is the repeating structure. These repeating structures are connected with the oxygen. Hence this connection is called as anhydride. This one is called as anhydride. So here in this repeating structure, total 2 carbons are present. Hence we can say the ethanoic, because wherever acid is there, that acid is replaced by the anhydride. So this name is called as ethanoic anhydride. Whereas in this compound, so this is the benzoyl group, this is the repeating structure. So these two repeating structures are connected with the oxygen. So this name is called as anhydride. So this name is called as benzoic anhydride. So this is the nomenclature of the writing of anhydrides. So coming to the preparations of the carboxylic acids, so first preparation is hydrolysis of nitriles, amides, esters. On hydrolysis of nitriles, we can prepare the carboxylic acids. On hydrolysis of amides, we can prepare the carboxylic acid. On hydrolysis of esters also, we can prepare the carboxylic acid. So this is the methyl cyanide. So this compound's name also called as nitriles according to the IUPAC nomenclature. So methyl cyanide on hydrolysis, then what will happen in the cyanide? Triple bond is present between the carbon and nitrogen. That bond is undergoing to break and forms the acetic acid and nitrogen, which is liberated as the ammonia. This is the first preparation. So in the second preparation from the amide, so amide is nothing but C double bond O NH2. This linkage is called as amide. So this is the acetamide structure, which is also on hydrolysis. So here this C double bond O NH2, this bond is undergoing to cleavage. So in the water, so H minus as well as H plus is present. So here this bond is undergoing to cleavage and forms the acetic acid as well as ammonia. Here in this reaction, it will undergoing to nucleophilic addition reaction. Nucleophilic addition reaction, because here oxygen, which is having the more electronegative atom, which takes its pi bonding electrons towards to the oxygen, then the carbon will get positive charge. So in the water, oxygen, which is having the lone pair of electrons, which donates electrons to here, so simultaneously this pi bonding electron shifted to the oxygen. So like this, this compound involves in a nucleophilic addition reaction, and this bond is undergoing to cleavage and forms the acetic acid as well as ammonia. So next preparation from the esters. Esters are nothing but R, C, O, O, R dash. This such type of the formula compounds are called as esters. Esters on hydrolysis in the presence of the base. So here R, C double bond O, O, or this C double bond OR linkage is undergoing to break, and this R dash O, which is produced as the alcohol, whereas the C double bond O, this compound is eliminated as a carboxylic acid. So here also this compound also involves in a nucleophilic addition reaction. Generally, wherever C double bond O groups are present, then all those compounds involves in a nucleophilic addition reaction. We will also later we will discuss in the chemical properties. We can discuss. And the next preparation is from the Grignard reagent. So here Grignard reagent is nothing but alkyl magnesium halide. So when it reacts with the carbon dioxide, so in this Grignard reagent, R is existing as a minus charge, whereas magnesium halide which exists as a plus charge. So here in the C double bond O, in carbon dioxide, oxygen will carry minus charge, whereas carbon will carry plus charge. So here this R group will attach to the carbon, whereas here oxygen, which is having the minus charge, which is attached to the MgX. So this addition product will form. On further hydrolysis, here this bond will break. This C double bond O MgX, this bond is undergoing to cleavage and produces the carboxylic acids as well as magnesium hydroxy halide, which is the byproduct. Like this, we can prepare the different types from the different methods. So here from the acid halide, this is the acid halide or C double bond X. This linkage is called as, these compounds are called as acid halides, and these are the anhydrides. These are called as or C double bond O. This repeating structure. RC double bond O, which are connected with the oxygen, is called as anhydride, whereas here RC double bond O, OR, this linkage is called as esters, whereas amides RC double bond O NH are called as amides, RC triple bond N are called as nitrides. Acid halides, anhydrides, esters, and amides, all these compounds are derivatives of the acids. So here in the acid, OH group is replaced by the halogen, then which will produce the acid halide. Whereas in carboxylic acid group, OH group is replaced by this link RC double bond O group, then those compounds are called as anhydrides. So in carboxylic acid group, OH group is replaced by the OR group, then which will produce the esters. In carboxylic acid group, OH group is replaced by the amine group, then which will produce the amides. So all these four compounds are derivatives of the acids. So all these compounds on acid hydrolysis, which produces the carboxylic acid. That means from the carboxylic acids, we can prepare all these four compounds, and also from all these compounds also we can produce the carboxylic acids. So here acid halide on hydrolysis, X will liberate by X is replacing by the OH group, which produces the carboxylic acid group. So in the anhydride, this here C double bond O, this link bond will become break and produces the carboxylic acid group. Similarly, in the ester also, or C double bond O, here C double bond O, this bond is undergoing to break and produces the carboxylic acid group. Similarly, in the amide also, C double bond O NH group is this bond is undergoing to break and produces the carboxylic acid group. So here also, as we discussed earlier, nitriles on hydrolysis also, which produces the carboxylic acids. So these are the few preparation methods of the carboxylic acids. So there are some special methods are there for the preparation of the aromatic acids. So in the aromatic compounds, by oxidizing aromatic alkanes, which are by oxidizing by KMnO4, that is potassium permanganate, or potassium dichromate, that is K2Cr2O7, or dilute HNO3 nitric acid in the presence of any three of the oxidizing agent. Suppose if the aromatic ring which is having any side chain or any alkyl group, so that alkyl group which is converting into carboxylic acid group, and irrespective of the length of the this alkyl group, irrespective of the length of this alkyl group, whether it is only 1 carbon, 2 carbon, 3 carbon, that complete group which is converting into the carboxylic acid. For example, if we see here, this is the toluene, this compound name is toluene. When it is oxidized with either potassium permanganate, potassium dichromate, nitric acid, any of the oxidizing agent, in the presence of any of the oxidizing agent, this CH3 completely undergoing to oxidize and produce converting into carboxylic acid. This compound name is called as benzoic acid. For example, if you see here, this is the isopropyl group, which is a substituent which is present on the benzene ring. This common name is called as fumine. So here, this complete alkyl group is undergoing to oxidize and produces the carboxylic acid group. So here, only one methyl group is present. Here, three carbon chain which is having the three carbons. Even though irrespective of the length, this compound, this alkyl group is completely converting into carboxylic acids. So similarly here, this compound name is called as orthogylene. Here two methyl groups which are in 1,2 position, hence we are calling as ortho. And if two methyl groups which are present on the benzene ring, then that name is called as gylene. Here, whenever this gylene and reaction with the potassium permanganate, that is oxidation, will take place. So this benzene which is having the two methyl groups, that means two alkyl groups, then these two alkyl groups undergoing to oxidize and produces the two carboxylic acids. So orthogylene on oxidation with the potassium permanganate, which produces the phthalic acid. That means aromatic ring, if the alkyl substituent is present, irrespective of the length of the alkyl group, that alkyl group which is converting into the carboxylic acids. And coming to the Physical properties of the carboxylic acids. Here, carboxylic acid molecules are associated through intermolecular hydrogen bonding and exist as a associate molecule. So carboxylic acids which involve in the intermolecular hydrogen bonding and also exist as a associate molecules. Hence, because of the intermolecular hydrogen bonding nature, compared to the alcohols, even though those two compounds having the same molecular weight, and but this compound which is involving intermolecular hydrogen bonding, hence melting point and boiling points of the carboxylic acids which are higher than the alcohols. And similarly, the carboxylic acids which are having the C1 to C3 carbons, then those compounds are colorless liquids. And also those carboxylic acids which are having the C4 to C9 carbons, those are also oily liquids. Those carboxylic acids are also oily liquids. And higher number of more than the C9 carbons carboxylic acids which are existing as a colorless solids. And generally any carboxylic acids, for example, if you take the acetic acid CH3 C double bond OH, this any carboxylic acid which existing as a dimer form. Dimer form is nothing but a dimer and also which is existing in a cyclic dimer. Nothing but because this carboxylic acid which is forming the intermolecular hydrogen bonding. Intermolecular hydrogen bond is nothing but one molecule which makes the hydrogen bond with the another molecule. With the another molecule is called as intermolecular hydrogen bond. So here this is the 1 mole of acetic acid, that is CH3 C double bond OH. This is 1 mole of acetic acid, whereas this is the CH3 C double bond OH. This is the another mole of acetic acid. So here total 2 moles of acetic acids are present, but here one acetic acid which makes the hydrogen bond with the another acetic acid. Like this, two within the between the two molecules of the acetic acid, two hydrogen bonds will be possible, hence which forms the cyclic form. So here one molecule of the acetic acid, this oxygen which is directly connected to the hydrogen, which makes the hydrogen bond with the another carbonyl oxygen, another molecule of the carbonyl oxygen, whereas another acetic acid carbonyl oxygen which makes the hydrogen bond with the another acetic acid. So like this, which acetic acid which exists as a dimer form. Hence, compared to the alcohols, this acetic acid which existing as a dimer form, which is forming the hydrogen bonds. Hence, these compounds melting points as well as boiling points are high. So I hope you are all understood the today's class. In today's class, we were discussed about the carboxylic acids, nomenclature and classifications like monocarboxylic acids, fatty carboxylic acid, dicarboxylic acids, and aromatic carboxylic acids. And also we have discussed about the preparation methods of the carboxylic acids like hydrolysis of acid halide, hydrolysis of the anhydride, hydrolysis of esters, hydrolysis of amides, hydrolysis of the nitrile. From all those compounds on hydrolysis which produces the carboxylic acid, and also preparation methods of the Grignard reagents also we have studied. And also we have discussed about the physical properties of the carboxylic acids. Thank you for your patience listening. So in the next class, we are going to discuss about the acidic nature of the carboxylic acids and chemical properties of the carboxylic acids we are going to discuss. Thank you.